Okay, so part two then of this question, what it's asking you for. So this was the first part that we worked out. So we have a normal distribution. So the second part then, which is this part, a person is chosen at random from those surveyed. Okay, so we had 1,200 people surveyed. Um, so a person is chosen at random. So use the empirical rule to find. So we have the empirical rule to find the probability that the person has an IQ score between 70 and 130 points. Now, if we have a look here at this is what's known as the empirical rule. So basically what the empirical rule is all about. So what it says is that if you take a survey and you plot the frequency, let's say of in this case IQ scores, and if it follows a normal distribution, then it'll have a bell curve like this. Now, if it follows a normal distribution as well, then we have this what's known as a standard normal curve, and we can follow what's known as the empirical rule. And basically what that means is that we have these numbers, so 68%, 95%, and 99.7%. So what it basically means is that 68, so if it's a normal distribution, 68% of your um, of your results will fall within one standard deviation of the mean. So remember, this is like one standard deviation here. So this would be plus one standard deviation, and this is minus one standard deviation. So within here, basically what you're going to get, like roughly, if it follows a normal distribution, 68% of of your data should fall within this normal distribution. So in the case of this data here, so what we're saying is that 68% of the people, their IQ score will fall within plus or minus one standard deviation from the mean. So that would, this here would account for the 68% because it's following a normal distribution. Then 95% of the measurements will be within two standard deviations. So this will be minus two and this will be plus two standard deviations. So roughly 95% of your IQ scores should fall within these parameters here. So this would be, let's say, within plus or minus two standard deviations, you're going to have roughly about 95% is going to fall within this. Okay, so 95%. That's what we mean, that's what we have here. And then finally, then nearly all of your results then should be within three standard deviations. So plus or minus three standard deviations, and this will be your minus three, and this will be your plus three. So again, all it's saying is that, so if you're to take the area that's taken up by plus or minus three standard deviations, it's going to be this whole range from here right the way to here. So nearly all of your measurements, or in this case, all of your IQ scores will fall within that range. So that's what we mean by the empirical rule when we're dealing with a standard or normal curve. So what it's asking us then is it's saying that using it, like, what is the probability that the person has that? So using this distribution here, so what's the probability? So the probability is going to be equal. So it's going to be, let's say, your probability of getting, let's say, between 70 to 130 points. Okay, so this probability is going to be basically what it's the number of favorable outcomes divided by the number of all outcomes. Okay, so in this case, like if we think about, let's say, like what percentage is that? So we have, so basically what we have here, so where is this, so what we're talking about here, so between 70, so we're talking about between here and here. Okay, so that's two standard deviations, two times the standard deviations. So it's between 130 to 100, between 130 to 70. So we can see here that the probability of that, so there's 95, so it's 95 over 100. Okay, so the number of favorable outcomes that you could have, in this case, if we were to use it, would be, this is going to be equal to 95 over 100, which is going to be equal to 0.95. So in this case then, your answer then, so the probability, you can write it as it's equal to 0.95. You could write it like that, or you could write it as 95%, or you could write it even as 95 over 100. So that'd be the answer. That's the answer to that question.